Hello everyone. In this video, let's discuss about Equatable protocol, which is very essential for our day-to-day programming. So first to start with, so what is this Equatable protocol? Why that is needed? So what? Who is conforming to this protocol? Which and all that has to conform to, and also we will discuss in this tutorial. So a type that can be compared for value or equality. So generally in our daily programming we see, like for example, let's say I have two strings, current address and selected address, both are equal for now. This is what we do, but what is this operator, and how come this is all these primitive types like strings, integers, everything these are having. For example, not only this, for example, val1 is equal to, let's say, 10, let val2 is equal to 20, if val1 is equal to val2 do something. So if I run this, there are no build errors, nothing at all. So how come this is working fine? How come this operator is coming to the primitive types? Why? Because they conform to the Equatable protocol. These int, strings, doubles, floats, everything and all. So types that conform to the Equatable protocol can be compared for equality using the equal to operator, and not equal to also we can apply. So this equal to and not equal to, both we can apply using the not equal to operator. Most basic types in Swift standard library conform to the Equatable protocol. Most basic types, in the sense these integers, strings, this and all, they conform to the Equatable protocol. Okay, then what about our custom types? For example, let's say I have my custom object address, correct? So this is my current address object, this is my selected address object. Okay, so if we compare two custom objects, let's see what happens. For example, if I try to do the same, earlier we did the strings, but now it's not strings, these are objects of address model. Now what happens? Let's say it is saying binary operator cannot be applied to two address operands. So what does it mean? So that means it is not allowing. I think something is missing. So then what we can then what we need to do actually? So instead of doing this, what we can do, we can write a method inside this address, and is equal to address, like this we can do. And what we can do, if for example, if first start with, if country, let's say, if self, we call it as, if for example address is equal to, as both are address is a string, I think we can apply it. If address is equal to address dot country, it is actually, sorry, it is country. So let's say for now it's only country, let's say, or I can write it like, and if for example this country is equal to, and just a state, correct? So let's say this is the condition, both country and state should be equal. Let's say this is the condition, a hypothetical condition. So like this I can write, and just a second. Okay, so whether equal or not, we need a bullet value. First I am checking like whether countries are equal, then I will check like if states are also equal. So this is my condition. So binary operator cannot between. Okay, now instead of doing this, what I am supposed to be doing this is whether it is equal to selected. Now it works fine, there will not be any build errors. And if we have an array of address and we need to find the address in that, and we cannot directly use contains by passing elements like below, correct? So for example, let's say I'm taking this, for example, so these are all the use cases of Equatable. So slowly we will get into, so after facing all these challenges, then we will understand, okay, why Equatable protocol got introduced. That is the reason I am just giving some background on this. So for example, let I have an array called addresses, where I have a couple of addresses, let's say, I'm sorry, okay, and city, say some city, yes. So for example, let's say San Francisco and California, let's say, okay, and let's say the same, let's say San Francisco, let's say, let's add the same addresses, which is fine for now. Okay, these are the addresses. So in this I need to contains, so sorry, okay, so this is what I need to do. Let's say for example I have addresses, so as you can see I need to go with where see here, if I need to search whether my particular address is there or not, then again I need to write the condition here, like conditions in where for example this result, let not use it. Now I need to tell like address dot country is equal to or something like that, correct? This condition that I need to give the same condition, maybe address dot country is equal to something like this, then only it will say. But see, I need to write a method if I need to do the comparison or equal to or not equal to. If I need to check whether they are equal or not equal to, then I need to go with a method. Or if I need to just search, it's just a search operation I want to do. Search, you can call it as search. If I need to find that in a collection, so what I need to do, I need to go with the contains with, this is with a where class, correct? Where clause, and we cannot directly use contains by passing element like below, like so. For why? Because for example, if this is the case, let's say this is the current address, selected address list, so let address list, if I say for example if I am having something like this, this, let's see the difference. What is the difference between primitives dot, see, it is having two contains. Why? Because these are primitive types which conform to the Equatable protocol. That means directly you can give, see, two contains, one with the where class, one with normal. So but whereas if you can see here, if there are custom objects, so if you try for address dot contains, you will see only where class. Why? Because these are not conforming to the protocol. That means the engine, the Swift cannot understand whether these are equal or not. Why? Because they are not conformed to the protocol. So it is saying like you put the condition. Why? Because you don't already have the condition, you put the condition, correct? So we have to use arrays contains where clause here. So then only I think we can search. Then this of course is it's a tedious job, correct? So this is obviously tedious job, and finding is also very difficult. So then so this is the use case of Equatable protocol actually. So adding Equatable conformance to your custom types means that you can use more convenient APIs when searching for particular instances in a collection. So more convenient APIs in the sense like this address list dot, these convenient APIs if you need to have like other simply, or this, see, this is a convenience, this is a convenience. So these convenience stuff you can have only if you conform to the Equatable protocol. So Equatable is also the base protocol for the hashable and comparable protocols, which we will discuss in the coming tutorials, which allow more uses of custom types such as constructing sets or sorting the elements of a collection. So we'll discuss that in the upcoming tutorials. So this tutorial, let's focus only on Equatable protocol. And so how can I do it? How can I conform to? So earlier prior to Swift 4.1 version, we need to implement this I'll discuss. So for example let's say Equatable, so this is what I need to do, and I don't need this. Now value of address has no member. Okay, so let me delete this. I don't need this. I don't want to go with this kind of approach, so I'm deleting this. So now it is conformed to the Equatable protocol. Earlier 4.1 version we need to implement the Equatable conformance, but now the like this static method called this we need to implement, but as these are structures, as these are value types, now Swift itself will do this equality logic, and so we don't need to explicitly conform to the protocol. From Swift 4.1 onwards, we don't need to write the boilerplate code for equitable protocol unless we need to change the logic. Unless I need to change the logic. For example, let's say this is not a address. For example, this is a string, let's say. So let me add the initialization method. I think the code has come. Now it will start complaining. Why? Because class is not the class is a reference type. Now it is asking type address does not conform to the equitable protocol. Do you want to add the protocol stuff? This is what I am discussing about. So for structure it didn't ask. Why? Because from Swift 4.1 onwards we don't need to write the boilerplate code like this, code for equitable protocol, unless we need to change the logic. Now here I would like the I would write the code saying that if this is LHS equality, if there is an equality, of course always you will be have LHS is equal to RHS. This is what you are searching, you are trying to find. Then it's like LHS dot I'll start with the country. I'll write the same condition is equal to, I can apply double equal to here. Why? Because country is a string and it's a primitive type, and equitable obviously applies for it automatically, is equal to RHS dot country, and the same condition I'm writing, and LHS dot city. Now I go with state first. City is fine for now. RHS dot state. So this is the condition we thought of writing, right? So I think now magically I have a class, I have this, that and all, but as you can see address list was never used. Okay, let's remove it. Let's warnings are not good. Current address is not used. Okay, addresses. So instead of me doing all this, what I would do is I'll just add it here. Current address object comma selected address object comma, for example it's let it be India, let it be, let's say, Delhi or Mumbai is state. Sorry, let's add state. So let me go with Delhi. Just a second. Delhi comma Delhi, let it be. So this, let this be San Francisco, and let this be California. Okay, so sorry, California. Now again, so for example, let's say home address, current office, let's say selected office address object, let's say office address object, let it be any state, but San Francisco, America, let's say. So I have addresses, and this is also one of the addresses. Now see how easy it is. Like if if office address object is equal to selected address object, see, no issues. Why? Because now it can compare. Why? Because you have defined like if country and state are equal, they are equal, correct? So that's basically. So now technically this office address object and current selected address object are same. Why? Because we are just checking country and state in the equitable method, the static equitable method. So technically this and this both are equal. Now I can, if so what I can do, if selected address or let okay, selected address object, if selected address object is equal to office object, next let me just print it like yes, they are equal. Okay, and they are equal. Perfect. This, see, I'm able to apply this now, which is one of the advantages of protocol. Next, now again let's try if it contains. See, now I've got two. see convenient APIs, this is what we were discussing about, correct? Which is now I can directly give like addresses dot contains. Now I will say like city something I will give, but state something I will give San Francisco. Technically speaking, does it contain? Yes, it contains. Or let's say okay, New Delhi and India. Oh, it contains. Why? Because it is not mandatory, you give empty also. So technically speaking, contains will give true or false. But if you have to use this contains, if you go to the, you need to the element in your array should conform to the equatable protocol, then only you can give. See, this you can use it only if your element conforms to equatable protocol actually. Okay, so equatable protocol. So I'm going back. Result of contains is not used if. Yes, contains, of course it should give me, it should go to this if and print. Yes, it does, correct? So this is one convenient API, this is one convenient API, and this is not only equality also I can compare. Let's see if it is working or not. Let me quickly run it on the simulator so that I can show you in the output. See, this is as simple as that. I go here, I go to the model, I define this is my equality. Like I can change the logic, I can go ahead with the logic. Tomorrow if I need to change something, I will just come and here say like addresses are equal if countries are equal. Like it's my logic, my wish. Okay, next I go. So maybe I need to call this method. I have, okay, let me call this method. I have just taken a method to explain it, so let me run it again. Deliver to current address. Yeah, current address is called selected address. This of course primitives. Yes, these two are equal now, and yes it does. So like this we can simplify finding objects now using contains. Why? Because contains where clause is not required actually. Why? Because we already confirmed into the equatable protocol. That's why equatable makes it easy for easy of comparing custom objects and finding custom objects in a collection. So we can rely on automatic synthesis of equatable protocols requirement for a custom type when you declare equatable conformance in the type's original declaration, and your type meets these criteria. So for a structure, if it is a structure, there are some criteria also. If it is a structure, all its stored properties must conform to the equatable protocol. So like for example, let's say what I'm trying to say is for example it's product. Okay, so let's say let ID of the product, let name of the product, let description of the product. Okay, so if for struct all its stored properties must conform to the protocol, then I think you don't need to implement or something. It will not complain. Why? Because these are all our primitive types, integer, structure. The moment you add something, for example, let me take another class called delivery person. Okay, same, let's say this guy is also having the same description. I not needed. Okay, let's add the initializers. Okay, let's add the initialization method actually. Okay, for example, if it is having it will start complaining. Now type product does not conform to protocol equatable. You are saying something, boss, but this guy is not comparing. Then if you want this, first what you need to do is this delivery person has to conform to the equatable protocol. Then I think you can do the equatable conformance. Okay, so same way like enum, all its associated values must conform to the equatable. and enum without associated values has equatable conformance even without the declaration. So there are some criteria over here. Okay, so that's basically the equatable protocol. Now if I write the equatable here, and it will complaining that you need to address it, and if I say like if LHS dot ID, if ID is equal to same, we shouldn't be bothering about the name of the delivery person. So now it will not complain. Cannot assign ID is a lit constant. Oh sorry, it's not assignment, it's just checking. Okay, now it doesn't raise a concern. It will not raise a concern saying that so this will automatic synthesizers will work for structure. Why? Because these are value types. Why? Because everything inside the structure is having equatable conformance. Integer, string, and delivery person also equatable. That's what I was talking about. Okay, so that's basically the equatable protocol, and it's very useful for your daily programming language. And there are some examples that I wanted to cover, like comparing structures or classes. For example, if you are comparing structures or classes, so equal to we just discussed. Classes, structures also we just discussed. Classes you don't structures you don't need to conform it to explicitly. Why? Because structure automatic synthesis so the correct word to use it is automatic synthesis of equatable protocol works here. That is one. Sorting and searching, this we already just discussed. So if it is conforming to the equatable protocol, you can do contains, first index, anything. Otherwise you need to write the where class. If it is not conforming to the equatable, then the only option you will be having is let persons dot first index okay, maybe it is a structure with primitive elements, that is the reason it is giving. Otherwise, so we need to write the where class. For example, if it is, let's say, class, then let's say persons dot first index of, it will throw an error. It's a playground, so because it's not having any initializers, or we can keep this, let's keep this here and try, let's keep this here and try. Instead of this, let me put it here. Let me add, we discussed contents, let's discussed first index and all this stuff. So for example, okay, this is this. Now persons dot if I argument, okay, let me build it. Okay, let me add the initializers instead of giving this. It's name and days, correct? Okay, let me quickly add in. Init is already there. Okay, now it should not complain. Now the problem is we first index will be having only where class. You can't write it like this. You can't pass a person and check it. Why? Because it's not conforming to the equatable protocol. That's the problem here. That's what I was discussing. If it is searching, sorting, contains, or anything. Now if I do this for this person equatable protocol, so let it complain, let me write it, and I would say like LHS dot name is enough actually, is equal to RHS dot name. Okay, let's add age also. Let's add age also. Now right, now this works. Now there will be more convenient API. If I need to give the first index, you can pass a object directly, or you can write a where class. This we already discussed for contains, and so that's what it is basically. So let's not get into this, and okay, this let it be structure so that it will not complain. Okay, now let's see. Okay, now using equatable with enums, even for enums we can go ahead with the equatables. For example, if it is having an associated type, then we can do this equal to operator only if this we need to write, of course, only if it is conforms to the equatable protocol, then only we can check two enums with the associated types. Okay, so that is with the equatables. Using equatable with generic, same, this we discussed in our earlier tutorial where generics with constraints and all, where if there is a generic type, if it is conforming to the equatable protocol only, I think we can apply, we can call this method. Otherwise we can't call this method. So I can call contains value 3 in numbers only if these numbers contain to the equatable protocol. For example, if I randomly pick something like let's say class product, let id int the same, let id int, let name string. Okay, so now if I create a product, okay, let me write the initialization quickly. Since it is playground, it is asking, so okay, let me quickly write it for you. id name, it's like self dot id is equal to id, self dot name is equal to name. Correct. Now if we can see, if I add one more person here, or product here, id1 name something, then it will start complaining. Heterogeneous collection. First in place it has to be this, and after the type any cannot conform to the equatable protocol. What it is saying is this one is not conforming to the equatable protocol, so contains you cannot call it. Why? Because if you are passing a value type, it should conform to the equatable protocol. Correct? So that's basically the use cases of equatable protocol. I hope this post is useful. Thank you.